A rare visitor from deep space is flying through our solar system. The object now officially named 3E Atlas. Astronomers have spotted another mysterious interstellar visitor racing through our solar system. And this one is mind-blowingly huge. Dubbed 3I/Atlas, it's barreling past at over 150,000 miles per hour and could stretch up to 12 m across, far dwarfing its predecessor, Oumuamua. Telescopes worldwide are scrambling to study its strange glow, trajectory, and ghostly haze. Some wonder if it's just a frozen rock or something far more extraordinary. Could this colossal traveler from another star hold secrets that redefine all we know? The breaking discovery. Something extraordinary happened in the night skies of late June 2025. Astronomers detected a mysterious object speeding through our solar system at a mind-boggling pace. This wasn't just another space rock or comet. This visitor came from beyond our solar system, making it only the third confirmed interstellar object ever discovered. The object, now officially named 3I/Atlas, has the entire astronomical community buzzing with excitement. When it first appeared in telescope data, nobody knew exactly what they were looking at. Was it just another asteroid, a comet, or something entirely new? As more observations poured in, one thing became absolutely clear. This object wasn't from around here. What makes this discovery so incredible is how rare these interstellar visitors are. For centuries, we've been scanning the skies, cataloging thousands of asteroids and comets that orbit our sun. But objects from other star systems, those are exceptionally rare finds. Before 2017, we hadn't confirmed a single one. Now with 3I/Atlas, we found our third in less than a decade. This isn't just a random space rock passing by. It's a messenger from another star carrying secrets about distant worlds we may never visit ourselves. The story of how we found it, what it might be, and where it's going next reads like a cosmic detective novel with twists and turns that have astronomers staying up late glued to their telescopes as it races through our cosmic neighborhood at an astonishing 152,000 miles per hour. 3I/It gives us a brief but precious opportunity to study material from beyond our solar system. It's like receiving a package from a place we've never been. A scientific gift delivered across the vast emptiness between stars. The discovery story. The story of 3I/It began on what seemed like an ordinary night between June 25 and June 29, 2025. The Atlas system, which stands for Asteroid Terrestrial Impact Last Alert System, was doing its regular work, automatically scanning the night sky for any objects that might pose a danger to Earth with powerful telescopes positioned in Hawaii and South Africa. This automated guardian watches over us day and night, looking for the unexpected. And unexpected is exactly what it found. At first, the object appeared as nothing more than a faint dot moving against the backdrop of stars. The system flagged it as interesting, but not necessarily extraordinary, just another space rock to add to the ever-growing catalog of near-Earth objects. It was initially given the unmemorable designation of 11PL3Z, just a string of characters in the vast database of sky objects. Then came Tuesday, July 1, when astronomers using a telescope in Chile noticed something strange. The object they spotted wasn't following a normal path. Its trajectory seemed off. It was moving too fast, and its orbit didn't make sense if it belonged to our solar system. Follow-up observations on July 1 and 2 confirmed these suspicions. This object wasn't circling our sun like everything else in our neighborhood. It was just passing through. The breakthrough came from an unexpected source. An amateur astronomer named Sam Dean decided to look through older images taken by the Atlas telescope from late June. There it was, the same object captured days earlier, providing crucial data about its path across the sky. This discovery allowed scientists to calculate its trajectory with much greater accuracy. By Wednesday evening, the Minor Planet Center, the official organization that keeps track of objects in our solar system, had received over 100 confirmed sightings from telescopes around the world. Some astronomers even reported signs that it might be a comet with a faint haze of gas and dust surrounding it. With all this new information, scientists were confident enough to give it a proper name. 3I/Atlas. The 3I part signifies that it's the third interstellar object ever confirmed, and Atlas honors the telescope system that first spotted it. Paul Chaz, director of the Center for Near-Earth Object Studies at NASA's Jet Propulsion Laboratory, explained that the object is traveling incredibly fast. There's no doubt it came from interstellar space. If you trace its orbit backward, it seems to be coming from the general direction of the galactic center. It definitely came from another solar system, though we don't know which one. The confirmation of a third interstellar visitor in less than a decade has astronomers wondering if these objects are much more common than we previously thought. Perhaps our improved technology is finally allowing us to spot visitors that have been silently passing through our cosmic neighborhood all along. A stranger in our midst. What makes 3I/Atlas stand out from the countless other objects zooming around our solar system? For starters, it's moving at an absolutely mind-boggling speed of about 152,000 miles per hour. That's fast enough to travel from Earth to the Moon in just over an hour and a half. Most objects in our solar system move much slower because they're bound by the Sun's gravity. 3I/Atlas, on the other hand, is just passing through, barely affected by our star's gravitational pull. Its speed alone tells scientists that this object isn't from around here. When they trace its path backward, it doesn't loop around the Sun like comets and asteroids from our solar system do. Instead, its trajectory points toward deep space, suggesting it came from the direction of the galactic center, though its exact star system of origin remains unknown. Then there's its unusual brightness. When Harvard astronomer Avi Loeb analyzed the data, he noticed something remarkable. 3I/ is reflecting a surprising amount of light for an interstellar object. This could mean one of two things. Either it has a very reflective surface or it's enormous. If its surface is dark, like most asteroids, 3I/ would need to be around 12 miles, 20 kilometers wide to reflect that much light. That's massive compared to our previous interstellar visitors. Was estimated to be only about 100 m long, while Comet Borisov was roughly 400 m across. If these size estimates hold true, 3I/Atlas would be dozens of times larger than either of them. Another intriguing aspect is its apparent come-try behavior. Some telescopes have detected a faint coma, a hazy envelope of gas and dust surrounding the object. This suggests it might be a comet, but one quite different from those in our solar system. As it gets closer to the Sun and heats up, we might see it develop a more visible tail, which would help scientists understand its composition. Its orbit is also unique. Most objects in our solar system orbit roughly along the same plane. Picture a giant disk with the Sun at the center. 3I/, however, is plunging through this disk at a steep angle, further confirming it didn't form alongside our planets. The more astronomers observe 3I/Atlas, the more they realize just how special it is. It's not just another space rock. It's a time capsule from another star system, carrying secrets about distant worlds we've never seen. Every night that telescopes turn toward this visitor, we learn something new about the universe beyond our solar system. The predecessors. To fully appreciate why 3I/ it has astronomers so excited, we need to look at the short but fascinating history of interstellar object discoveries. Before 2017, we had never confirmed a single visitor from beyond our solar system. Not one. For all of human history, we had only observed objects that belonged to our cosmic neighborhood. That all changed on October 19, 2017, when Hawaiian astronomers spotted something unusual using the Pan-STARRS telescope. The object, later named Oumuamua, meaning scout or messenger from afar in Hawaiian, was like nothing we'd ever seen before. Its shape was bizarre. Either cigar-like or pancake flat. Depending on the interpretation, it was tumbling through space, reflecting sunlight in a way that made its brightness vary dramatically. What really puzzled scientists about Oumuamua was its acceleration as it left our solar system. It sped up slightly, which isn't what gravity alone would cause. Normally, objects slow down as they move away from the Sun's gravitational pull. This unexpected acceleration sparked intense debate. Some suggested it was outgassing, releasing invisible gas that acted like a subtle rocket engine. Others, including Harvard's Avi Loeb, proposed more exotic explanations, including the possibility that it might be an alien light sail or spacecraft. Left our solar system quickly before we could get a good look at it with our most powerful telescopes. It left behind far more questions than answers. Then came our second interstellar visitor, discovered in August 2019 by amateur astronomer Gennady Boris. Unlike the mysterious Oumuamua, this object named Comet 2I/Boris in his honor was unmistakably a comet. It had a visible tail and behaved much like the comets in our own solar system. Boris was easier to study because it was spotted months before its closest approach to the Sun. Scientists determined it was about 400 m across and composed of materials similar to those found in comets from our outer solar system. This similarity was intriguing. It suggested that perhaps comet formation is similar across different star systems. These two visitors were tantalizing glimpses of objects from beyond our solar system, but their differences raised many questions. Oumuamua didn't look or act like anything we'd seen before, while Boris seemed remarkably familiar. Now with March 8, we have a third data point that might help us understand what's normal and what's unusual about these cosmic wanderers. The rapid succession of these discoveries, 3 in less than a decade after centuries of seeing none, has made scientists wonder if interstellar objects are actually much more common than we thought. Perhaps they've been passing through all along and we simply lacked the technology to detect them until recently. The Cosmic Journey. Let's follow 3I/Atlas on its remarkable journey through our solar system. Right now in early July 2025, it's zooming through space at over 152,000 miles per hour. Currently positioned about 3.8 times farther from the Sun than Earth is. That's beyond the orbit of Mars, but well within the asteroid belt. Unlike objects that belong to our solar system, 3I/Atlas isn't circling the Sun. It's on what astronomers call a hyperbolic trajectory, essentially, a one-way path that will take it through our solar system and then back out into interstellar space, never to return. If we could trace its path backward through space and time, it would lead us toward the center of the Milky Way galaxy. However, pinpointing its exact star of origin is practically impossible. Space is vast, and during the millions of years it might have traveled, stars themselves have moved. It's like trying to figure out which raindrop came from which cloud. The connections have been lost to time and distance. Looking ahead, 3I/Atlas has some interesting encounters on its schedule. On October 3, 2025, it will make its closest approach to Mars. This will be the first time it passes near one of our planets, giving astronomers a chance to measure how the planet's gravity might slightly alter its path. Then on October 23, 2025, 3I/ will reach perihelion, its closest point to the Sun. Even at this nearest approach, it will still be about twice as far from the Sun as Earth is. This distance is important for a few reasons. First, it means the object won't get intensely heated by the Sun, which could have caused it to break apart if it's a fragile comet. Second, it ensures that 3I/Atlas poses absolutely no threat to Earth. Speaking of Earth, our planet will be on the opposite side of the Sun when 3I/Atlas reaches its perihelion. The closest it will come to us is in December 2025, and even then at a very safe distance. After that encounter, it will begin its long journey back into interstellar space, gradually picking up speed as it escapes the Sun's gravitational influence. What's fascinating about this journey is that 3I/ is essentially a tourist in our solar system, a brief visitor passing through on its eternal voyage through the galaxy. It formed around another star perhaps billions of years ago and has likely been traveling through the empty void of interstellar space for millions of years before chancing upon our cosmic neighborhood. And just as it arrived unannounced, it will leave again, continuing its journey to who knows where, carrying with it a brief history of its encounter with our Sun and planets, a history that will never be read by anyone unless it happens to pass through another star system with intelligent beings capable of detecting it. A scientific goldmine. The discovery of 3I/Atlas isn't just an astronomical curiosity. It's a scientific goldmine that could revolutionize our understanding of how planetary systems form throughout the galaxy. Think about it. Until recently, the only planetary system we could study up close was our own. Everything we know about planet formation, asteroid composition, and cometary behavior came from objects that formed around our Sun. Now, with 3I/AL, we have a genuine piece of another star system passing right through our cosmic backyard. It's like being able to pick up and examine a rock from Mars without having to send a rover there. An opportunity to study material that formed under completely different conditions than those in our early solar system. What makes this opportunity even more valuable is that 3/ appears to be much larger than our previous interstellar visitors. Its size means we can get better observations, more detailed spectra, and potentially even determine its composition with greater accuracy than was possible with Oumuamua or Borisov. If 3I/Atlas is indeed a comet, as some early observations suggest, it offers us a chance to compare its ice, dust, and gas content with comets from our own system. Are the same chemicals present? Are they in similar proportions? The answers could tell us if the ingredients for life as we know it are common throughout the galaxy or unique to our corner of space. Another exciting aspect is that we're catching this object relatively early in its journey through our system. Unlike Oumuamua, which was already on its way out when discovered, we will have months to study 3I/Atlas as it approaches the Sun, reaches perihelion, and then departs. This gives astronomers time to coordinate observations using different telescopes and instruments around the world and in space. The timing couldn't be better from a technological standpoint either. When Oumuamua passed through in 2017, the James Webb Space Telescope wasn't yet launched. Now with Webb fully operational along with other advanced observatories, we have unprecedented capabilities to study this interstellar visitor in detail. Perhaps most importantly, each new interstellar object we discover helps us answer a fundamental question. How common are these visitors? Before Oumuamua, some scientists estimated we might see an interstellar object once every few decades. Now, with 3 confirmed in less than a decade, those estimates are being dramatically revised. It seems likely that interstellar objects pass through our solar system much more frequently than we thought, perhaps multiple times per year, with most going undetected because they're too small or too distant from Earth. If interstellar objects are indeed common, it suggests that planetary systems throughout the galaxy routinely eject material into interstellar space. This in turn tells us something about how planetary systems evolve and interact with each other across vast distances and timescales. Unanswered questions. Despite all our advanced technology and brilliant scientists, 3 of 8 guards many secrets that leave astronomers scratching their heads. One of the biggest mysteries is its exact nature. Is it a comet, an asteroid, or something we don't have a category for yet? Early observations show hints of cometary activity, a faint fuzzy appearance that suggests gas and dust.